Okay, today we're going to continue our discussion and start talking about volume of prisms and cylinders. So our first thing I want to go over with you or remind you of is what is volume. So I've got a definition here. The volume of a solid is the number of cubic units contained in its interior. So imagine taking a cube or a rectangular prism, and you are, filling this thing up with as many cubes as you can. And the number of cubes that you fill it up with is considered the volume. Volume is measured in cubic units, and so we will use this unit to the third power, whether it be centimeters or inches, as we calculate. Okay, we've got a couple postulates here. First one is the volume of a cube postulate. And remember, a cube is basically a three-dimensional square, so all sides are congruent. So the volume of a cube is the cube of the length of its side. So if you notice your formula right here, all three sides in this case are considered S. So volume would be one side times another times a third, or we can just consolidate that to sides cubed. Postulate 28, volume of a congruence postulate. If two polyhedra are congruent, then they have the same volume. So I feel like that postulate probably seems pretty self-explanatory. And then volume addition postulate. The volume of a solid is the sum of the volumes of all its non-overlapping parts. Okay, so let's move on to two other formulas that work for all prisms and all cylinders. So the volume of a prism. The volume of a prism is capital B times H. Okay, and then this is really important here. Capital B is the area of the base, and then of course H is going to be the height. So when we say height, we want to clarify that to be the distance between the bases. So I'm going to add a note down here. Height is the distance between the bases. And I'm going to add in here, it's the perpendicular distance. So the shortest distance would be the perpendicular distance. So if your prism is like laid over on its side, it's not necessarily how tall it is, it's the distance between the bases. Capital B, since that's the area, if you have a triangular pyramid, or I'm sorry, a triangular prism, then your area formula is 1/2 base times height. If you have a rectangle, then your area formula is just base times height. Or maybe you have a trapezoid. So that formula for capital B would be 1/2 times base 1 plus base 2 times your height. So capital B can be multiple formulas, it just has to be the area of the base. The next one is about cylinders. So it's technically still the area of the base times the height, but all cylinders have this circular base. So we can go ahead and plug in the formula for area of a circle because it will always be the same. So pi r squared would be area of a circle, and then times height would complete the volume. So pi r squared h. Okay, let's go through a few examples. Okay, first one says, find the volume of the solid. It is a right trapezoidal prism. So we're going to start with the formula for the volume of a prism. It is the area of the base, capital B times h. Okay, now area of the base, though, I need to do the area of the trapezoid. So area of trapezoid. Okay, so let's do a little calculation off to the side. The formula for area of a trapezoid, 1/2 base 1 plus base 2 times the height. Okay, so we're looking at either the bases are parallel to each other. So I'm looking at just one of these trapezoids right here. Okay, so I have the 1/2. So the two bases in my trapezoid are parallel to each other. So 14 is one of them. And then the bottom section is 6, which corresponds to the 6 labeled at the bottom here. And then the height is the distance between those two bases on just the trapezoid, so that is going to be our 3. Okay, so let's calculate here. We're going to do half. 14 plus 6 is 20 times 3. So half of 20 is 10. So it looks like the area of the trapezoid is just 30. Okay, so that is just capital B. So back to my volume, I now know it's going to be 30. And then this height, 5 is the height of the prism, the distance between the bases. So then I'm going to plug my 5 in here. And so my volume is going to be 150 units cubed. My units are centimeters. So 150 centimeters cubed is the volume. Okay, let's move on to our right cylinder. So always start out with formula. V equals pi r squared h. Okay, now cylinders, I just need to plug in the radius and height. So pi, my radius is given to me as 9. So 9 squared. Your h, still distance between the circular bases, is going to be 6. So I'm going to first write this in terms of pi. So when I take 9 squared, which is 81, and multiply by 6, I get 486 pi. So if I had directions that said leave it in terms of pi, I would stop here. So this is in terms of pi. Or you might be given directions that say exact value. If I'm going to do the approximate volume, I will go ahead and multiply by pi, and we'll just round to the nearest 10. So this would be approximately 1,526.8. And again, the units are cubed, so this would be feet cubed. Okay. All right, let's take a look here. Got a couple more to look at. All right, next example says use the information to at this time solve for x. So I see the volume is provided as 396. I have my dimensions here on my prism. So my formula, this is a prism. Volume equals area to base times height. So I know the volume of 396. Okay, area to base. So this is some kind of rectangular base. So the area of the rectangle would just be the base times height or length times width. So that's going to be 11 times x. And then the distance between the top and bottom, the bases, is another x. And then now I just solve for x. So I've got 396 equals 11x squared. I need to divide off 11. So I end up with 36 here. 36 is equal to x squared. Solve for x. So we would square root both sides. So when I square root both sides, I get the positive or negative version of 6. But since we're dealing with a shape, I can eliminate the negative answer. So x, I'm going to then say is 6, and our label is centimeters. So this is a rectangular prism, not a square prism, or not a cube, I guess. Okay, I'd like you to pause the video and try number 3 on your own. And then when you get to a point where you have an answer or you get stuck, go ahead and come back to the video. Okay, we are dealing with a right cylinder. We know the volume. So start with your formula. Volume equals pi r squared h. So let's plug in what we know. We know the volume is 277. So pi, I don't know radius, but I know the height is 5. So I need to keep r, or r squared in my equation, and then plug in my height. Okay, so I need to solve for r. So you could do this in 1 or 2 steps. You could start by dividing by 5 if you wanted to separate this out. So if you do 277 divided by 5, we get 55.4. And so I still have pi r squared. Now I need to divide by pi. So if I divide by pi, I get about 17.63. And then I continue solving by taking the square root. So I've got R is approximately 4.2. Now, go back to the directions though. We actually need the diameter. So if I know that the radius is 4.2, my diameter is going to be twice the radius. So I'll have to take my 4.2 and double it. So diameter is about 8.4 and my label is 8. Okay. Well, if you would go ahead and try some of those on your own, here is the assignment, and we will check it the next class period.